We have seen the binomial expansion of this x plus y whole power n is nc0 x power n plus nc1 x power n minus 1 y plus nc2 x power n minus 2 y square plus and so on ncn x power n. Okay. Now in place of y simply substitute a for any constant. Any constant coming means what will come? The same thing. Wherever y is there, there and all, a will be there. So we'll be having nc0 x power n plus nc1 x power n minus 1 into a plus nc2 x power n minus 2 into a square plus and so on ncn a power n. Suppose we have negative in the sense x plus a whole power n, okay, it is x minus a, where y power n should come, yes, at last. Oh, I wrote x power n, sorry, my bad. This y power n. Okay, now a is substituted. Did I wrote a correctly? Yes, correctly. Then x minus a means wherever a comes in the odd power. See, this x minus a also we can convert into x plus something, that is x plus of minus a whole power n, like we can consider. And here minus a means wherever a comes, we should replace with minus a in the existing expansion. Okay. So here in the existing expansion, wherever a comes in the odd power, we will get positive. Sorry, odd power we will get negative. Even power we will get positive. So here we are going to rewrite this. So that is nc0 x power n. Actually a power 0 is hidden. 0 is even number. So we'll be having positive 1 plus nc1 x power n minus 1. A comes in the odd power. A comes in the odd power means in place of a what we are substituting? As I told you earlier, minus a I am substituting. So minus a when you substitute, this term will get negative. So minus x power n minus 1 into a, and then plus here a square is there. When you substitute minus in there, it will become positive only. So plus nc2 into x power n minus 2 into a square and so on. But at last we have some ambiguity whether it is positive or negative. It depends, right? It depends on the value of n. If n is odd means negative, even means positive. So to come up with this uncertainty, we will put one minus 1 power n, ncn a power n. Matched, right? Alright. Now this is such a large expansion. We should make it as a compact formula, like we should compress it. For that we have one tool, that remember sigma notation, that summation notation, remember. So this x plus a whole power n, just observe the things, this n is same in all these terms. So we have sigma n. The varying things and all are what? Non-varying things, x will be there for sure. nc, here one number is there, x power n is same, minus this number is varying, and a is there, a power something is varying. That varying thing alone we should replace with the variable. Remaining and all same, fix the things. Okay, wherever the number is changing, that place only I put dash. Now look at the first one. First one, it starts with 0. Whereas nc0 x power n minus 0 a power 0 works fine. We get the first term, is it? And nc1, that means in our place 1 is there, 1 is there, 1 is there. It works fine. So we'll replacing that with r, a power r, and this is r varies from 0 to n. The starting value of r is 0 to the ending value of r is n. Okay. Now can you say for this x minus a whole power r, same r is equal to 0 to n, the same NCR x power n minus r a power r, but there is a problem. What problem? Very, very, very confusing, right? See, this is a big, large expansion. Okay, lengthy expansion that we have to compress it as one formula. That one formula, we should observe it. That observation gives us n is not varying, c is fixed, this suffix number and all, suffix number and n minus coming one number, this number all varying. Okay, so I said that r varies from 0 to n, right? We substitute r is equal to 0. The sigma notation works like that only, right? See, we substitute the first value in the expansion, put plus and then go substitute the next value. Remember, suppose they say sigma n, that means that n is equal to 1 to 5. That means what? First we will put first value 1, put plus, then second value 2, put plus 3, plus 4, plus 5, like that. Suppose we got n plus 1, that n varies from 0 to 5. That means what? First term. In this one, the very first beginning value we should put 0 plus 1. Next year, after 0, what is there to reach 1? So reach 5. That is 1 plus 1. That means in place of n, wherever this variable comes, we'll replace and add everything. That's what the sigma notation works. Here also like that only. If you put r is equal to 0, first term will be what? NC0 plus x power n minus 0, a power 0. Put plus. Then next value of r0, okay, 0 to n. You should substitute and add everything together. So r is equal to 1 will substitute. That means NC1 into x power n minus 1 a power 1 plus and so on it goes. At last value NCn x power n minus n a power n. Does that exactly matches with this formula? It's done not. See man, x power n minus 0 is what? X power n. A power 0 is what? 1. So NC0 x power n. That is what the first term. Okay. Like that here. In place, as I told you while expanding this, in place of plus a, we have to put minus a. Here also we will put minus a. Minus a power r. That can be written like sigma r is equal to 0 to n minus 1 power r NCR x power n minus r a power r. That's all. This lengthy expansion, we just compressed it into the simple generator. That's all. Okay. Now we'll add these two things. Okay, now add these two things, man. This is the first equation, this is the second equation. Then when you add 1 plus 2, that means x plus a whole power n plus x minus a whole power. Why I am adding these two? To derive a new formula, that's all. Then here NC0 x power n, here also NC0 x power n. Left hand side I added, right hand side we should add. NC0 x power n plus NC0 x power n 2 times NC0 x power n. NC1 x power n minus 1 into a minus NC1 x power n minus 1 into a. They are the like terms. Cancel. Then these two terms will be 2 times. So all the terms will come 2 times. I mean the even powers. NC2 x power n minus 2 a square plus and so on. All the even terms will be there. Okay. And then when you subtract these two, x plus a whole power n minus x minus a whole power n. When you subtract, the second expansion is of change of signs, here minus plus minus like. So now all the odd powers will be cancelled. Then we will be having what? 2 times, did I say odd powers will get cancelled? Even powers will get cancelled, man. See, this even powers and all will become minus, minus, minus and all. So these two are like terms having the opposite sign, they get cancelled. All the even powers get cancelled and odd powers will be added. NC1, oh, I said odd powers will be staying. No, not all the even numbers. Even powers will vanish, odd powers will be there. Like NC1, x power n minus 1 into a plus NC3, x power n minus 3 into a cube plus and so on. Okay. Alright. A quick recap. We have seen what is binomial theorem. The higher powers of binomials, how that can be calculated. And then we come up with the general expansion and some observations based on the expansion. After that, some calculations like some alterations. Suppose here minus and all is coming, means what will come, like that we have seen. Okay. And then some deductions from that we have did, like adding these two will come what, will give what, subtracting these two will give what, like we have seen. That's all. Now, the number of terms. We have seen the number of terms in this one, first expansion. It is having n plus 1 terms. Okay. And in this one, this is also having n plus 1 terms. This is also having n plus. That's what we discussed previously. We observed, remember, when power is 0, it is having 1 term. When power is 1, it is having 2 terms. Okay. Like that, here also, this sum and difference will have what terms, based on what number it is. Like odd number means what is the sum of the terms, how many terms will be there. Even numbers means how many terms will be there. Suppose we have odd terms, odd number, n is equal to odd number. Odd numbers means here this both will have the same number of terms, that is n plus 1 by 2, that many number of terms will be there. For example, this is power 105, this is also power 105 is there. We can't expand and add all the time, right? By this formula, we can simply find how many terms are there. So it is 105 plus 1 by 2, 106 by 2. So totally 53 terms will be there. Without even expanding, we can say. Example I said, man, n is odd number means n plus 1 by 2 number of terms will be there. Okay, suppose n is even number, this addition will have, I will call it as 3, subtraction I will call it as 4. This addition will have n by 2 number of terms and this subtraction will have n by 2 plus 1 number of terms. Okay. Sorry, man. Even will have 1 term more. See, n is even means, shall I erase the upper part? Okay. See, if n is odd, this both 3 and 4 will have same number of terms. The number of terms is n plus 1 by 2. The addition is 3, subtraction is 4. Okay. If n is even, This 3 comes with the addition, right? One more extra, like n by 2 plus 1 number of terms will be there. This subtraction will have n by 2 terms will be there. Okay. Why? Because when n is even, we'll be having that more number of even terms, right? Because it is about even terms only. That 0 will be added here. Okay. So including this, that is n by 2 plus 1. And this is, here 0 will not be there. Exact count will be there. That is why n by 2 terms. Okay. That is it. Now we'll solve some examples. Can you just say a quick recap? Shall I raise everything?